All right, 8.3, and then we finish chapter 8. So relatively short chapter, little bit repetitive. Like I sort of foreshadowed, we're going to learn three types of confidence intervals. This is the third type of confidence interval that we're going to learn, and that is a confidence interval for a proportion. I think there's one generic problem and then two word problems. So let's go ahead and work through those three problems. Again, in theory, you've already done them yourself, and at this point, we're just comparing answers. So here's the generic one, number 17. Use the given data or given information to construct a confidence interval at the requested level. So it's very generic, but that's basically saying that we take a sample of 317 people, and 125 of those people have whatever characteristic it is that we're interested in. So I don't know, let's say that we're interested in blue eyes. So 125 out of 317 people in our sample have blue eyes. So let's make a 95% confidence interval for the percent of all people or all students or all whoever that have blue eyes. So anytime we're doing a confidence interval for a percentage or proportion of people, well, it starts off the same. We hit stats because it's stats class. We go to tests because it's useful on a test. But our third type of confidence interval is 1 prop z int. So still, the formula still has this letter z in it, so it's kind of a z interval. But unlike the first one, this is a z interval for a single proportion, just one proportion, whereas the z interval that we learned earlier in chapter 8 is an interval for a mean. And then we just fill in the information. There's less information to fill in for this third type of interval. The one thing we just have to be a little bit careful about is what it's asking for. So, I mean, this problem gave us exactly the information we need. Not all problems are so kind. When the calculator asks for x, x is the number of people in your sample that have the characteristic of interest. So here we were told that's 125. N is the size of the sample, that's 317. The C level is how confident we want to be, that's 95. So the tricky part is sometimes that X, because sometimes you're told 125 out of 317, but sometimes you're also told something like 50% out of 300 people. And in a situation like that, we have to do a little bit of work. We have to say, okay, what is 50% of 300? It's 150, and then we got to plug that number in for X. So again, X is never a percentage. That's a common mistake. X is always the number of people in our sample that have whatever it is we're interested in. So we plug all that in, we hit enter, and we get an interval between 34 and about 45%. So I think we look at our conclusion on the next slide. We would say that we're 95% confident that the true proportion of whatever of all people that have blue eyes is between 34 and 45%. Not too bad, right? So again, if you haven't already, pause it, do the two other problems, and then let's move on and take a look at them together. All right, so this one's about smartphones. So of young cell phone owners, we sampled 238 of them. 102 of those people said their phone was an Android. And so first question is just find a point estimate for the proportion of cell phone owners in that age bracket who have an Android phone. So the point estimate's just like a fancy word for the sample proportion. So that's just 102 out of 238. 102 divided by 238. We plug that into our calculator, and we get about 43%. So again, what that technically means is that 43% of our sample have an Android phone, but we want to know what percent of all 18 to 24-year-olds have an Android phone. So 43% of our sample, but we're interested in the percent of the population. Now, we'll never know that percentage exactly, precisely, unless we could somehow sample every 18 to 24-year-old. That's not going to happen. 18 to 24-year-olds are very, very, very elusive. There's no way we're going to track them all down and find out whether or not they have an Android phone. So instead, we're going to make a confidence interval and find a range of plausible values for what that overall percentage might be. So the book asks us to make a 95% confidence interval. For the proportion, right, there's that keyword that I'm emphasizing that's telling us to do a confidence interval for proportions of cell phone owners who have an Android phone. So 102 out of 238 have an Android phone. We want to be 95% confident. And there's our confidence interval. So, right, we would say, well, 43% of our sample has an Android phone. And based off that, we're 95% confident that somewhere between 36.6 and 49.1% of all, right, 18 to 24-year-olds have an Android phone. Now notice, even though we don't know the exact percent, that entire interval is less than 50%, isn't it? So we would be justified in saying, well, I think that the percent of all 18 to 24-year-olds that have an Android phone is less than a half. I don't know exactly what it is, but my entire confidence interval is less than 0.5, so I feel pretty confident in saying that I think it's less than a half. So that's the translation. I think I already said that. Oh, so here's actually something along the lines of what I was saying. If instead somebody said, hey, or an advertisement claimed that 45% of all 18 to 24-year-olds have an Android phone, we would actually not we would not dispute that claim. Agreed? That claim is actually quite consistent with our confidence interval. We say we don't know what it is, somewhere between 37 and 49%. So if someone tells us 45%, we say, yeah, that's believable. Oh, look at that! Very, very apropos example. Right after we've freshly given blood, right? So here's our volunteering example. The General Social Survey asked 1,294 people whether or not they performed any volunteer work. I'm going to argue that donating blood counts as volunteer work. And a total of 517 people, probably most of them from Math 121, said that they in fact did do some form of volunteer work. So what's our point estimate? Point estimate is just a fancy word for sample proportion. So the sample proportion is 517 out of 1294. Put that in your calculator. It's just about 40%. So 40% of our sample has done some type of volunteer work. But we want to know what percent of all people have done volunteer work, right? We want to know the population proportion. So there's that keyword that I'm emphasizing. It's the book's question. Make a 95% confidence interval for proportion. When I see proportion, that's where I'm thinking, okay, I'm going to use the 1 prop z int function in my calculator. There's all the information that I'm filling in. There's the actual interval. I'll summarize it on the next slide. We are 95% confident that the proportion of people who performed volunteer work last year is somewhere between 37 and 42.7%. Right, so right, somewhere in that 40-ish range. right? No less than 37, no more than that 42.6, somewhere between those two numbers. If a sociologist made the claim like, hey, people are really altruistic. In fact, I would argue that 1 in 2 people, 50% of all people, do volunteer work. We would maybe say, I don't know. Our data seems to indicate people are a little bit more selfish than that. We think that the true proportion of all people that volunteer is somewhere between that 37 and 43, which means we would probably disagree with that sociologist statement. They appear to be overstating how many people volunteered last year based on the data that we had accessible and that we plugged into our calculator. And that's that, man. Chapter 8 hopefully went a lot more quickly than Chapter 7. And so, of course, this may or may not change in the future, but at the time of narration, this ends all the material that'll be on your second exam. So hopefully this all made sense. If for some reason it didn't make sense, if for some reason you're just getting the problems wrong, every time you try it, it's not a big deal, right? You can get a problem wrong a million times, doesn't matter. As long as you get it right that 1,000,001th time, right? Sometimes it takes a while. I mean, true story, took me 5 tries to pass Calculus 1. Yeah, it took me a long time, but does it matter? Does those 4 failure attempts ultimately matter at the end of the day? Not really. The one that really matters is that 5th time that I passed it, and then I moved on to a life where I got to embrace my passion and my love of statistics. And it took some work to get there, but here I am. And of course, right, you may or may not be struggling. If you are struggling, it's natural to struggle. I struggle. People struggle all the time. Just do something about it, right? So hopefully this stuff's been clicking. It's been making sense. If you're still struggling with it, come talk to me. Shoot me an email. I would love to hear from you, right? And either I'll meet with you in person, or we can talk over some different options where you can meet with somebody, maybe some kind of free tutor or something like that, so we can try to get you on track, okay? All right, then let's go ahead and do that. Let's study hard, and I'll see you for your test.